Hey, unfortunately it's me again, but now I have to say unfortunately it's us again, because the topic we are covering today is quite more extensive. How to build your own synthesizer, not just mono synthesizer, but poly synthesizer. That's what we're doing right here. If we gotta delete this one. If we play this right here and connect our MIDI keyboard to Unreal Engine, we can play multiple notes, which is not as easy as you might think it is. In the last tutorial, we covered how to actually connect our MIDI device to Unreal Engine. If you missed that video, it is vital for this one, so please go back and check out how to set all of this up in the last video that is linked in the description below. But in this tutorial, we're going to focus on how to actually get a sound out of our MIDI keyboard and not just use the values for pretty things. Since this is a bit more complicated and I don't know where to start, and if we have a look at the already simplified code, I thought that I'd get some help and an outside perspective to ask questions if something is not quite clear. And Mrs. next to me hopefully will stop me if it's getting too complicated. And just to verify, you don't really know what is going on right here as well, right?
No idea.
No idea. Perfect. All right. We are starting. Last video, we already covered everything up until here. So we're getting our MIDI device controller, and every time we hit a note, we save it into a variable and we trigger this event. This custom event down here gives us a feedback of, okay, something is happening, trigger, and the timestamp when something was hit, which channel is triggered, which note is triggered on this channel, and the velocity of how fast this note has been played. This section right here is just our output for debugging purposes only. So we're formatting all of what we're getting out here into timestamp, channel, event, type, control ID, and velocity. If we play and you look on the left corner up here, if I press a button, it's telling me channel 8, note on, ID 65, and the velocity that I'm hitting the note with. So far so good? So far so good. If we take a closer look, when we're getting a note on signal, which is I press it, I get an ID and a velocity. If I release the key right now, you're getting the same ID, the same channel, but with a velocity 0. And I am not able to get a velocity 0 by pressing a button, no matter how slow I press it. So we remember velocity 0 on button press is always a release. That's important for later. But how do we actually get a sound out of our keyboard? Right now we saw that channel 8 is my keyboard down here. We play something, channel 8 is our keyboard down here. The pads up here are channel 10. This one is channel 16, this one is channel 8 as well, blah blah blah. Channel 8, channel control change, channel 8 up here as well. That's what we got to figure out and filter out. And this is what we're going to do here. We know that channel 8 is our keyboard and we want our keyboard. So we drag out our keyboard node and put it into a switch on int. What this is going to do is check for input. It's just a right click, switch on integer. This is how it will look per default. You just put in your channel ID in here, click on it and uncheck default pin, and it starts at channel 8. It does for my keyboard. It might vary for your keyboard. And I'm just adding as much pins as I need to. Before we saw that it's going up to 16. This button right here was channel 16, but we are today just focusing on our keyboard section down here because the same principle applies to everything. Any questions up so far?
So everything goes in and then you put it into different channels, or?
Yes, the signal goes in. The signal that we're getting in here, this is our timeline. So the signal is checking if the input is valid. If it's not valid, don't do anything. If it is valid, go ahead and control our switch on int. And the switch on int gets an input, our channel, which is the number 8, and then sees, okay, I am getting the number 8, so I'm executing whatever lies behind channel 8. And this is what we're doing right here. We're executing the path number 8 because it got the number 8 from our keyboard. The next step is rather unique probably to my keyboard, because as you saw before, my keyboards down here is channel 8, and also those knobs up here are channel 8 as well. And I don't, technically my module is channel 8 as well with the ID 1, but we're gonna ignore that for this section. So we need to find a way to exclude those knobs from my notes, because I don't want these knobs to make any sound. I don't care about them. I'm gonna trigger something else with these. So I know that channel 8 note ID, channel 8 21, channel 8 28. So everything between channel 8 21 and channel 8 28, I don't want that to play notes. That's what I'm excluding in here. Branching, if the played sound getting from my channel ID and my control ID, which is the note, lies between 21 or 28, that means it's the knobs up here. I don't want to have any sound. So if it's true, do something. We have not connected in on here. But if it is not between 21 and 28, it must be on here. So we're playing the sound, what is actually happening on here. So far so good?
Yes.
So far so good. But right now we are having a difficult problem ahead of us. And before I'm explaining what is going on here, let's just focus on getting one sound out of the system, because that is way more easy than getting 5 sounds out of the system. And for that, we are going to go to our plugins, edit plugin Metasounds right here, Metasounds. Oh, by the way, if you didn't have time to follow up on the last video, MIDI device support needs to be enabled as well. But Metasounds beta, I activated. It will tell you to restart the system, which is fine, which you can do if you want to. Create a new Metasound system. I already created one. On the right click, sounds, Metasound source. All right. I named it tutorial. It should be a fresh start. And that's what you're probably seeing on here. Out mono and nothing else. We want to create a sound. Right click, sine wave. This one is going to play us a sine wave with 440 Hertz, which is already quite progress. But we want something else. We want to trigger this sound with our keyboard. So we need some sort of input. Now input, let's call it key 1 for keystroke 1, and of the type float. Float. Perfect. Because as we saw, our note, our channel ID, hoppala, not the same one, yes. Our channel ID, control ID right here, this is equivalent to a MIDI note. Control ID is our MIDI note that is being played. Keep that in mind. I labeled it notes down here as well. Control ID is the note that is being played. And this one can be transformed from MIDI to frequency. Because if I have a browser tab open, I have not. MIDI to frequency chart. There's a chart. MIDI notes, key number organ is already responsive to some sort of frequency. That is good to know, but Unreal does it for you. MIDI in, frequency out, put it into the frequency, and we are all set. Additionally, every note that we're getting a lot more information. If you remember, we're also getting the velocity, and the velocity is sort of how loud something is being played. If you really jam on those notes, you're getting max velocity, you're getting max output. You just have to notice the loudest. So multiply the audio by a float, and this float should be another input, and we're calling it key 1 velocity. Velocity. Perfect. Again, this one is a float input. Connecting it on here and out on mono. There's a tractor going by the window right now. All right, we're gonna sort that out. It's a loud day today. It is important to know that you should keep this value between 0 and 1. If you exceed 1, which is possible, it will clip. What do I mean with clip? It will distort. It will push your audio above the maximum limit, but it will cut off everything above the maximum limit. So it sounds distorted and crampy. If you want to have that, you can have that. But just keep in mind that it will cut off everything above the max frequency. We'll take care of that later on in the code. But we need one more addition, and that's our envelope. Envelope, ADSR, envelope audio. What this is make our sound more beautiful. So right now, if we press a key, it would sound like, oh, we're multiplying it with 0. That's not what we want. If we right now press a key, it would just make boop and stop. And that doesn't sound like a piano at all. So we have our envelope that we're multiplying with our audio source as well. And here you have the settings for how long is the note sustain its value, and there is a slight delay and a reverb, and it makes it just sound more nice, like a keyboard, like a ding and not a ding, ding, ding. That's what we're going to do here, but we need another trigger. We call it key 1 trigger, and it is of the type trigger. There you go, key 1 trigger. And whenever this one is hit, we're gonna get whatever is coming into here and multiply it with our envelope on top and make it sound beautiful. This is one note in our tutorial Metasounds system. So far, so good.
So is the trigger something else than the key itself?
The trigger is something else. The trigger is just a signal for pushing.
Okay.
It's not, there's no value behind it. It's just a signal on, hey, something's happening. Just a 0 to 1 value, but only 0 or 1. It's triggered or it's not triggered. It's triggered or it's not triggered. So how do we access this right here? You know what? We're gonna push all of that to the side because it is non-essential right now and it's confusing us. We're gonna put in a dot in here and a dot in here, and we're gonna delete that dot, so we're gonna leave it here. Perfect. To access our Metasounds, we need a new audio component. If you click on Add an Audio, you're already getting Audio Tutorial. Tutorial is the name of our Metasounds. That's great. If you do not have that, just take the one that's solely labeled Audio. But if you click on this one, because I already have an audio component in here, which is coming to play in play later, it is suggesting, hey, you have another audio component, which is Tutorial. If not, just click on it, and on the right side, look for your Metasounds source. We named it Tutorial. It's already in Tutorial because Unreal Engine is smart. We're gonna drag and drop our audio component in here, and now we wanna set all of the parameters that we defined in here in our blueprint. How are we gonna do that? Set float parameter. Perfect. Target is our tutorial, which means it is our Metasounds system. It's taking our Metasounds system. All right, he knows where to look for the name, which is, for instance, our key 1. Copy, paste it in here, and now it knows what to do. It's triggering our float value, key 1, which is our MIDI keyboard, in the value of, and what value is it? It is the note that we are playing, the control ID. Right here that we're already checking. I'm just gonna click on here. That's the note we are playing. And this is how we play the sound. Compile, save. We need something else. We have quite the setup in here. We see the key velocity. It's another float parameter. Float parameter. This one is next in line, and we called it key 1 velocity. It has to be the exact name. It has to be the exact name. Key 1 velocity, and of course, we therefore need the velocity parameter, which is down here. I'm just gonna make it a bit more clear. This is our velocity. Again, if you click on this one, it is our velocity. It's coming out of here, our velocity. And lastly, we have our key trigger to make it sound more beautiful. This one is a trigger, execute trigger parameter. That's the last in line. And what did we call our trigger? Our trigger is called key 1 trigger. So far, so good. Any questions arise?
No.
No. So theoretically what should happen is I press a key. The system says, all right, channel 8 is coming in from our channel. 8 is coming in. I'm executing whatever is channel 8. Next, I'm checking if the channel ID, the note that we're playing, is not between 21 and 28 because those are the knobs. If it's not between those two, go ahead and trigger key 1 with our value, the note that we're playing. Next, get the velocity with the velocity that we're getting from this event, and simultaneously execute the trigger parameter. We have our control surge in this scene. We're just gonna drag and drop it in here. So if we play, we hear it is playing. And why is it sounding like crap? Because we forgot something that I was mentioning earlier. This value has to be between 0 and 1, else it is going to clip up into oblivion and being cut off at the root, at the max frequency of Metasounds. So the problem, let's ear rape ourselves again. The problem is if we click on it, you see have an eye on the velocity. It's 103. That's not between 0 and 1. So we're multiplying our input signal 100 times. So, and if, you know, we set our speakers louder, then we're just gonna, you know, our eardrums are gonna blow out through our noses. Which means the velocity has to be map range clamped between the values that something went wrong here. We don't want to have that. We want to have our value in here. We know that we get a value between 0 and 128 and automatically remap that between 0 and 1. So if the system is if this node is getting 128, it's a 1. If it's getting a 0, it's a 0. If it's getting a 64, it's a 0.5, and so on and so on. It's just interpolating between those numbers, if that makes sense. Yes, so if you play right now, we're not clamping anymore. Now you can play a single sound with a keyboard, but as you see, we cannot play multiple sounds. It sounds like crap. And this is where it's getting more complicated. Sort of more complicated, because to play more sounds, we need to adapt our Metasounds system. And how we do that is simply, and I mean actually simply just multiplying it 5 times. We just copy and paste the same thing 5 times, and we make sure to rename our inputs. Node 1, node 0, node 1, node 2, node 3, node 4, key press. You know, just make it different parameters so the system is not getting confused on what just actually happened. Key press 0 to 4, node 0 to 4, velocity 0 to 4. That is everything we did, and we routed it together in a mono mixer. We set it up to have 5 nodes. We can set it up to have 6 nodes. Mono mixer 6, for instance, this one has 6 inputs. We just actually need to copy paste this one a 6th time, make a node 5 out of this and a key press 5 out of this, but let's just keep it at 5. This, make sure that you do not make the mistake and leave the gain at 1, because then again we have the same issue of clamping. Put your input to something of 0.5 for starters. If it sounds good, 0.6. If it sounds good, 0.7. It seems to be good at 0.8 for me. Your mileage may vary. Does that step make sense? If you want to play more sounds, just copy this one 5 times.
Yeah, and what is the other thing? Input?
The other thing? What, this right here?
Yeah.
The input is just a float parameter. So float value, a value, no, not a value flow. I just think I made it an input, an all gain input. Yes. This all gain input is just a float parameter with a default value of 0.8. I can access it if I want to through the keyboard, through our, through this one float parameter. And then I say, all in, but I don't want that because I want to, well, you know, I just don't want that. But it is essentially just a simple float parameter so that I don't have to set all of those nodes individually, but with one slider. Okay, in addition to multiplying this 5 times, we still get the issue that we override each execution prompt. So even though we have 5 notes set up, we can't just press 5 buttons and call it a day. As you see right here. We have to do some mathematics voodoo shenanigans, sadly. And I am going to try to explain the voodoo shenanigans right now. Any questions so far?
All clear?
All clear. Getting the false up in there. Okay, it is important to know that this input is the note up here, and this input is our velocity, else we're just gonna have to go back and forth, but we don't want that. We do not want that. So we just remember this is the velocity line and this is the note line. So we're pressing a button on here. It says it is not a knob up here. So go into this channel and into this branch. And this branch is the first step into our unleashed hell. We have 2 more arrays. Array notes, get array notes, and array velocity, get array velocities. These float arrays are set up to have 5 elements. 0 to 4, array velocities 0 to 4 as well. Because we only want to play 5 sounds at a time. If you want to play 6 sounds, just add another one. However, we press a note and then we are checking, okay, is the note that is being pressed already in our array? Contains. Does this array already contain the note that is being pressed? If so, if true, okay, what we're gonna do, we are going to delete the position. Why are we going to do this? As we discovered before, I play the value, all right, ID 67 and velocity 120. If I let go, velocity 0. So we get 2 signals per press. We cannot jank it and have 2, no, we have to let go of the key in order to play it again. Which means if a signal is coming in that is already being played, obviously that is the note off command. There's no other possibility. So that is why we check, is this note that is coming in already being played? If so, that means this must be the note off command. So in the array, we're going to set the position of this note that is coming in, that is already stored, to 0 in your note value and 0 in the velocity index. So if this is the first note we're playing, then the first note, no, if this is the first note we're playing and we're releasing it, we're getting again the same command back. So the same note ID is coming back, but with a velocity of 0. It does contain the note. So the first position of the array, because it's the first note we're playing, is going to be set to note 0 on velocity 0 and not be audible anymore. Does that somewhat make sense?
Yes.
Yes. That is if this array is already filled with the note that is coming in. If we're pressing a second button, we're pressing the first one and a second one, for instance, and it checks, all right, the note that is coming in is not in the system already. So we're not going up here, so now we're going down here. We are going through this whole array for each loop with a break. So we're going through this whole array and we're looking for the first position with the note element 0. So that's essentially saying, all right, get the first position that is free, that is not occupied by anything. Get the first position that is null. If you have that, then break the loop and give me the index of that position in the array. So if the third or the second position is 0, it's going through index number 0. Oh, okay, there's something in there. Okay, 0. The first position, oh, there's already something in there. Second position, it is null. Stop. Array index number 2 is free. There's nothing in here. Also, give me the second position and set the second position to our note and our velocity. Velocity and note. We have two set array elements because we have our array nodes, which stores our note values and our velocity values in a separate instance. Does that make sense? That's probably a bit more complicated.
Why do we set note and velocity and nothing else? So before we had the trigger?
The trigger is more or less stored in our note. We just need to know the note in order to know where to trigger.
Okay.
Since this trigger does not carry any information at all. It is just, oh, I'm called or I'm not called. It's not transmitting any sort of value. It's just an I'm called or not called. That's why we don't need any information on this. We're just storing the information of our array nodes and our array velocities. If this is done, so again, we're playing a note. It is not already in our notes, which means we are finding the first position that is free and writing the information that we're getting, which is which note is played and at which velocity it is played, into the arrays, array nodes, and array velocity. If we let go, we get the same signal but with velocity 0. So the system knows, oh, this note is already being played, so this must be the off signal. Let's just free the array of this element and make the position available for other nodes that are coming in. If this has happened, then we're going to enter this majestically looking piece of code. We are again trying to catch the node that is coming in, node number 67, for instance. Find the node 67 in our array nodes. We know it is in there because we've already set it up right here and then. So we know that array 67 is in here. We just want to find the position of our node in this array. Position of the array is 0 to 4. Let's suppose this is the first key that we're hitting. Switch on int. So it's on the position 0. Perfect. So trigger everything that is on 0. If it's the second node we're playing, all right, 0 is already occupied. Let's trigger position number 1 and do everything that is on position number 1. Now, what is on position 0 and number 1, or number 2 and number 3 and number 4? It is our single node, but slightly modified. If you look at that, this is exactly what we built like 10 minutes ago, but just copied 5 times. It's exactly it. It's the same thing that we built up here last 10 minutes ago, but just copied 5 times. So you can see node 0, velocity of node 0, and key press. Node 1, key press 1. Node 2, key press 2. Node 3, key press 3. Which is all corresponding to node 1, velocity of node 1. Node 1, key press 1. Node 2, key press 2, velocity of node 2. This is all a magic that is happening, and it's just copied 5 times. To make it, it's maybe sound absurd, but to make it look a bit nicer, we're grabbing those array values, array velocity and array nodes, which is our information on what we just put in there, and say this up here is node 0 and node 1, and we want that to correspond specifically to our first input, to our 0 input of the array. So let's get whatever is stored in our first position in the array. So array nodes position number 0. What is in there? That is our node that we're playing, because we are triggering number 0. If we trigger number 3, because we have 3 nodes played or 4 nodes played, we are getting the 4th position of this array, node number 3, array number 3, because we know if 0 or 3 is being triggered, we only want what is on this corresponding channel in array velocity or array nodes. Does that make sense?
Yes.
Perfect, that makes sense. So we are getting array nodes number 0, which is probably our 67. If I press this one, 67. Oh, hey, this is node number 67. Give it back, and we get our velocity that is also stored on our first value. We clamp it between 0 and 128. So 0 and 1, and put that into our float. And we don't need to convey any sort of information. That's when both of these members are played, executes the trigger, just say Europe, 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 corresponding to whatever you are playing. This is essentially all the magic that is happening. I'm quickly plugging my Patreon again. If you don't know what is happening, you can get all of this from my Patreon link is down in the description below. I'm gonna make it a bit more tidy and clear up all of the space up here. That's not necessary, but you can get all of this and it should work with your setup as well. To see it all in action for the end of this video, we can hear that everything is playing fine. Everything is playing fine. We want to see it in action in our blueprint. We can go through it one more time. Let's make this window a bit smaller. There you go. We're going through here. We want to see everything. Okay, in order to see everything, I'm just going to make this a bit more cramped together. I don't care about being beautiful anymore. I'm just going to put that in here. Yes, exactly. So just remember, we are checking if this is between 21 and 28. So that's not essential to us anymore. We're going to play and press. If I press one button, what is going to happen is it sees that it is not contained in the array. So we're going to go through all of here. If I release it, it knows this key is already stored in our array. So we're gonna set it to 0. If you have I cannot point my mouse, but if you look up here, it says it's deleting the position. It's going through, it's deleting the position. It's going through, it's deleting the position. It's going through, it's going through, it's going through. It's deleting the second position, it's deleting the first position and the last position because those values are already stored. Does that make sense?
Yes.
Yes. If we press more than 5 values, I'm pressing 5. You see everything has been played. If we press a 6th one, it's just gonna override number 5. It's just gonna override number 5. That's how it is. That's how it works. That's how I figured it out, and it seems pretty easy. And you can modify it however you want. You can add your soprano and your zigzags and your whatever you can do with your Metasounds. I don't know, multiply it by a zigzag. Oh, not zigzag. It's with a saw wave, for instance. That would be a cool thing. But this is how you make your keyboard make sounds in Metasounds and in the Unreal Engine. And I discovered something earlier. That's quite sick, and I don't know why it's happening, but I'll take it anytime. Thank you very much. This was the tutorial. I hope it made sense. Did it make sense to you?
Yeah.
So I think it would make sense to you guys as well. And I appreciate you sticking around for half an hour, as I see in the recording. And if there is any questions, feel free to leave it in the box down below, in the comment box down below. Also, give me feedback on what you want to hear next. And again, check out my website and my Patreon, links in the description below. So have a great day, and I hope that I could help you save some time. Bye.